Here's a problem that looks very new to us, although we've actually done this problem before, although it did look different at the time. So I'm just going to kind of go through this problem, and if you remember when we did these earlier in the semester, great. If not, well, here's how we're going to do this problem. I'm going to start with the inside here, and what I'm going to do is I'm going to draw a triangle to kind of visualize what's happening here. So what they're telling me is that I'm looking for an angle whose sine would have a ratio of -1/3. Well, I want to figure out what quadrant I'm going to draw my triangle in. Recall that when we were working with inverse sine, I'm only allowed to pick from one of those two quadrants, and sine is going to be negative in this quadrant down here. So let's go ahead and draw that right triangle in. Always from the origin, my theta, the angle I'm looking for, is this reference angle right there. And then this ratio is really giving me the sides of the triangle. Remember that sine stands for the opposite over the hypotenuse. So they're telling me that one side is -1 and one side is 3. The hypotenuse will always be positive, so I know that that's +3, and then my opposite side must be the -1. Hypotenuse can never be negative, and the other reason I know that that side has to be a -1 is because it's counting down. So now that I've got this triangle drawn, let's go ahead and figure out what this third side of the triangle would be using Pythagorean theorem. Do you remember these problems yet? So I'm just going to call that side A, and so I'm going to figure out, or I'm going to work out a squared plus -1 squared. Remember that needs to be in parentheses. Actually, all the numbers should be in parentheses, but those -1s in particular may mess you up if you don't use parentheses. So then I have a squared plus 1. -1 times itself is +1. That's why I needed parentheses. That number is always going to be positive. And then equals 9, so I'll subtract 1 from both sides. A squared's got to be 8. And then I'll take a square root and find out that a is equal to the square root of 8. But that's not totally it, because as we've always done with square roots, I need to try to simplify this. So if you need help, you can go back and look for a video. Otherwise, this is where we just did our factor tree and looked for pairs of numbers. The pairs get to go out of the square root, so I can simplify the square root of 8 down to 2, and then that single number stays inside, so 2 square root of 2. Once this triangle has been figured out, finishing the problem is actually really easy. We can find any ratio we want to find. This time, they're asking us to find the cosine. So I'm now out of those brackets. I'm asked to find the cosine of the angle. Well, to do this, it's as easy as we've done before. I'm just going to set up a ratio. So the cosine of theta is equal to the adjacent side, which is the side we just found out to be square root of 2/2, over the hypotenuse, which we knew was 3. And then I would look to see if I could simplify this. I can't. There's no square root in the bottom, so there is going to be my final answer, the square root of 2 square root of 2/3. So as I said, we've done these problems before. They just looked very different, but we're going to do them the exact same way we've done them before.